Hey everybody, welcome to today's webinar, How to Conduct Bivariate Analysis, the Bivariate Test Key. I'm Bill O'Bannon of Stats Whisperer. I will be your presenter for today. Now, the introduction. The goal of today is to share tip number one with you. There'll be more tips coming suggested by number one, I guess. This is a part of a larger 5-week webinar on the process of data analysis, but that discussion is for another day. Today, we're going to be talking about the critical content you must know to conduct bivariate analysis, which is the bivariate test key. Now, the glory of the bivariate test key. So if you're a learner, you're a researcher, you're doing data analysis, you need the bivariate test key. If you're an educator and you're experienced and you have this key memorized, your chances are your students or your mentees really benefit from the test key. So the question is, how can you examine a one-on-one relationship between two variables? For example, if I wanted to know if owning a pet affects your level of happiness in life, how could I determine that? So you could define these relationships using bivariate analysis. Now if we break it down linguistically, you have bi, which means two, and var, which means variable. So bivariate analysis is an analysis between two variables. Now choosing the correct test. The key to choosing the correct bivariate test has to do with the structure of the two variables that are being compared to one another. Now when we talk about variable structures, we can consider three. Continuous, such as maybe confidence, measured on a scale of 1 to 100, with 1 being no confidence and 100 being total confidence, and all the grades in between. And number two, categorical with two categories, such as do you own a pet, yes or no. So the two categories being responded to are yes or no. And number three, categorical with three or more categories. So let's say education, if we looked at it in three categories, high school, college, or other, that would be a three-category variable. Now here's the bivariate test key. This is very valuable, although I don't actually see it written down a lot, which is kind of the reason that I'm presenting it here tonight. So if you have variable A is categorical through categories and variable B is continuous, you would run a t-test, right? That's the bivariate test to use. If you had a categorical variable that was more than two categories, three or more, and variable B was continuous, you would use an ANOVA. And if variable A was continuous and variable B was continuous, a correlation. And if you had two categorical variables, irregardless of the number of categories, you would use a chi-square. So let's plug in the variables we've already discussed into this table to make it a little more user-friendly and detailed. Now remember, we said in the beginning we have happiness. We were trying to describe happiness. That was our dependent variable. So we're going to make our independent variables all the other variables we've discussed: owning a pet, education, and confidence. So what we're trying to determine here is what's that one-on-one relationship with each independent variable with the dependent variable. In other words, what's the relationship between owning a pet and your level of happiness? What's the relationship between your level of education and your level of happiness? What's the relationship between your level of confidence and your level of happiness? So we wanted to find each of these relationships. But because the variable structures are different, we need different tests. So here we have plugged in those variables. So variable B, as much as we can, we put happiness, because you often like to put your dependent variable here and your independent variables here, just for the sake of organization. So we have our categorical own a pet, yes, no, right? Categorical, two categories, a continuous. Like we said, you would find that relationship, define that relationship at the bivariate level with a t-test. Here we have categorical more than two categories, three or more. Education, we're relating that to happiness, which is continuous, so you would use an ANOVA. Over here we have a continuous measure of confidence, a continuous measure of happiness, so you would use a correlation. Now whenever you do like a dependent variable thing like I'm doing here, you're going to have one left out because here's the dependent variable, and if it's categorical, you have categorical and categorical, and you have to use a chi-square. So just for a proxy, for the sake of showing what you would use for a chi-square, we have our categorical education and our categorical owning a pet, and you would use a chi-square. So more glory for the bivariate test key. Now essentially what we did here is we condensed 4 chapters in a typical statistics book into one key. So normally you have a chapter on a t-test and a chapter on an ANOVA and a chapter on a correlation and a chapter on a chi-square. So the thing is a lot of the times when you get done with one chapter, you forget what was in the last one you read. So here's a good way of getting the crux and putting it all in one key. Now the other side of that is you have to learn the rest of the 4 chapters, because if that's all you needed to learn, then there'd be no reason for the big thick book. So we left a lot out here too, like some of the tests have assumptions, that must be satisfied before you run them. Sample size is always an issue, so there are ancillary issues that you need to address. But right now we're just kind of giving a very, very broad view. All right, now tomorrow we'll do another little webinar like this, very short one, just on like tips. Tips shouldn't be too long, or else they're lessons, right? So we'll conduct the 4 bivariate tests. Now that's not the most exciting thing. The most exciting thing is we're going to get the output, and we're going to apply the 20-80% rule in interpreting the statistical output quickly and effectively. For anyone who's ever done analysis and you have your printout after you do a statistical test, you may stare at that printout and you may say, what is this sea of numbers? It's a soup of numbers. So, and of those numbers, there's like a few really important ones. So 20% of the numbers will tell you 80% of the message of that test. So if you don't know which numbers are critical, then all of them look of equal importance, and that's where it gets cloudy. So tomorrow we'll discuss how you could look at 20% of those numbers on the output and determine 80% of what that test is telling you. And the 20-80% rule is a Stats Whisper original. So if you wanna know it, you got to show up. Anyway, that's the end of the webinar for today. Thanks for tuning in. And as always, more tips can be had by signing up for our newsletter at www.statswhisper.com/newsletter. Okay, thanks a lot. Bye-bye.